Hi everyone, I'm very happy to present my work today on differential susceptibility effects on the development of social behavioral control. So let me first quickly introduce myself. My name is Simone Dobbelaar and I'm a PhD candidate at Leiden University and Erasmus University Rotterdam. And I work on the LSID study, which is the Leiden Consortium on Individual Development. And within the LSID study, we focus on the social development from middle childhood to early adolescence, which spans approximately 7 to 13 years of age. And this is an important developmental period because it's marked by an increase in social experiences and social evaluations, for example, at school or among friends. And these positive peer evaluations can result in pro-social behaviors such as sharing or helping, but negative peer evaluations can also result in aggressive or retaliatory behaviors. And such aggressive responses can then result in a negative spiral of even more peer rejection. So it's important to learn to control your behavior in such situations. And this controlling, we also call it social behavioral control. And in this talk, I will specifically focus on 3 aspects of social behavioral control. First, we used a test replication design to investigate the neural correlates of social behavioral control in childhood. Second, we were interested in the development of social behavioral control. And finally, we investigated whether social environmental effects, such as parents, influenced the development of social behavioral control. And specifically, we were interested in the question, which children are most responsive to those changes in the social environment. So in our first study, we studied the neural correlates and age effects of social behavioral control in childhood. And we used the social network aggression task to measure social behavioral control or aggression following social feedback. And in this task, participants filled out a personal profile and received peer feedback on their answers. And this peer feedback could either be positive, neutral, or negative. And subsequently, they were instructed to send a noise blast towards the peer who gave the feedback. And they could decide the duration of the noise blast themselves. We use this noise blast duration as a measure of social behavioral control or aggression following social feedback. And for this study, we were specifically interested in neural activation during this noise blast event. And we tested these questions in the LSID study, and the design of the LSID study allowed us to test our questions in 2 independent samples of 7 to 9 years old. So we had a test sample and an independent replication sample. And all participants in the LSID study are twins, so we corrected for the fact that they come from the same family in our analysis. So our fMRI results showed effect of feedback condition on activation in the dorsolateral prefrontal cortex. And specifically, there was most DLPFC activation during responses to positive feedback and least DLPFC activation during responses to negative feedback. And when we correlated this DLPFC activation to the behavior, we found a brain behavior correlation. And this correlation showed that participants who showed more DLPFC activation during the noise blast showed shorter noise blasts, or less aggression, or more social behavioral control. So this showed that DLPFC activation was meaningfully related to aggression or to behavior. And additionally, we were interested in age effects in childhood, and we found age effects on both behavior and neural responses. Behaviorally, we found that older children showed less aggression or shorter noise blasts following positive feedback, and longer noise blasts, more aggression, following negative feedback. On a neural level, we found that older children showed more DLPFC activation, but only following positive feedback. In other words, older children showed more differentiation in behavioral and neural responses to social feedback. Thus, in this study so far, we found a possible neural mechanism of social behavioral control in the dorsolateral prefrontal cortex, and we found age effects on behavioral and neural correlates of social behavioral control. But we were additionally interested in longitudinal trajectories of development from childhood to adolescence. And also, we were interested in those effects of the social environment and specifically of parents. Parents are one of the most important socialization agents in childhood, so their behavior might affect the development of social behavioral control. And we specifically focus on parental sensitivity, and this is the ability to notice and adequately respond to child signals. We do this because it's previously been associated with increased pro-social behavior and decreased externalizing behaviors. But the impact on social behavioral control in adolescence is less clear. So that's what we focus on in our next study. But not all children might be equally responsive to changes in their social environment, so changes in parental sensitivity. So therefore, we also focus on the question, which children are more receptive to parental sensitivity changes? And the differential susceptibility model proposes that some children are more susceptible to changes in their environment, such that they might be more vulnerable in negative environments, but thrive in positive environments. So in this study, we test the differential susceptibility hypothesis, and we test whether temperament works as a differential susceptibility marker. We hypothesize that children with a high reactive temperament or higher reactive temperament show less social behavioral control in an environment of low parental sensitivity, but more social behavioral control in an environment of high parental sensitivity. Whereas children with a low reactive temperament might be less influenced by parental sensitivity. So if you're interested, you can read more in our pre-registration, but for now, I'd like to show you some preliminary results. So again, we use the LSIT study to test our questions, and we specifically focus on the middle childhood cohort, which spans the period between 7 to 13 years of age. We measure parental sensitivity with the Etch-a-Sketch, and this is a parent-child interaction task in which the parent and the child had to cooperate to make some drawings, and some managed to do so quite well. But their interaction was recorded and coded by trained coders, and they used the Erickson subskills for supportive presence and intrusiveness. And we averaged those two subskills into one measure of parental sensitivity. We used the first 3 time points of the middle childhood cohort to measure parental sensitivity. Social behavioral control was measured with the social network aggression task, which I explained before. And we used data of the first, third, and fifth time point for the behavioral and neural correlates of social behavioral control. So for now, I'd like to show you some results of our preliminary analysis. And first, we will look at the developmental trajectories of noise blast duration and DLPFC activation. And as you can see here, this is what we saw before. Between 7 and 9 years of age, there was a rapid decrease in noise blast duration following positive feedback. But our longitudinal analysis showed that from 9 years onwards, there's actually a rapid decrease in noise blast duration following negative feedback. Thus, there seem to be differential longitudinal trajectories for responses to positive and negative feedback. For DLPFC activation, we saw a rapid increase in DLPFC activation during responses to positive feedback. But then from 9 years onwards, we see that the activation for both types of feedback seem to slightly increase, but the trajectories for both positive and negative feedback seem to follow a similar shape. For our final aim, we tested whether the development of parental sensitivity in childhood was associated with social behavioral control in early adolescence. And parental sensitivity showed fair consistency over time with an intra-class correlation of 0.44. But when we modeled the linear development over time, we did not find variation in development between persons. So all participants showed a similar slope in trajectory. However, there were differences in the starting point of parental sensitivity. So therefore, we tested whether the starting point or intercept of parental sensitivity was associated with social behavioral control in adolescence. On a behavioral level, we did not find a relation between parental sensitivity and noise blast duration in early adolescence. And also on a neural level, we did not find a relation between parental sensitivity and DLPFC activation in early adolescence. So taken together, our application study revealed a robust neural basis for social behavioral control in the dorsolateral prefrontal cortex. Second, we found differential longitudinal trajectories for responses to positive and negative feedback, where responses to negative feedback might be developing a little later in childhood. And finally, so far we found no relation between parental sensitivity in childhood and social behavioral control in early adolescence. But it could still be that there is a subset of children that is more susceptible to variations in parental sensitivity. So therefore, our next step is to test for differential susceptibility effects by temperament. And ultimately, these findings might help us understand why some children are more prone to aggression than others, and also which children might benefit most from positive environments in order to thrive throughout their development. And with that, I'd like to thank my co-authors. I'd like to thank the LSIT research team and all participating families for their involvement. And I'd like to thank you for your attention.